Now we're going to do mixed numbers. Okay, so nothing really changes. You're still following the same rules, but now we have mixed numbers rather than just fractions. So in this real world link, all right, it says the eyeball of an Atlantic giant squid is about 12 times as large as the average human eyeball. So the average human eyeball is 1 1/4 inches across. So that's how wide it is. So the average human eyeball is about 1 1/4 inches wide. Okay, now it says use the bar diagram to compare that to the squid eyeball. So this is the average human. Okay, this is the squid's eyeball, how wide it is, right there. Okay, so what you're having to do is just fill in this bar diagram. I don't know why this is not working. This doesn't make any sense. All right, let's see if we can get this to work over here. All right, we'll just use this pen, I guess. All right, so the squid eyeball, all right, is going to be, so then we have 1 1/4 right here, because they said it was 12 times as large. So we got to get 12 1 1/4 in there. So we have 3, 4, 5, 6, 7, 8, 9, 10, and I might add a little bit more because I want too big. So all those should be 1 1/4, okay, because it's 12 times as large. Okay, get your math book out. So if you look at this, this is how big the squid's eyeball is. This little thing right here is a human eyeball, okay? So rather than having to do that every time and write this out, what is the multiplication expression that we could show to find the size of the squid's eyeball? What multiplication expression can we write out? So we just multiply, so we don't have to write all this out. Hannah? By what? By each other. No. How would we do this? How many did we put there? How many is there? Zach? 12. So 12 times what? 1 1/4. Because this is a lot easier to work with than having to count this up each time, because that was 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4, so on and so on and so on. Okay? Take it. If you don't have it, just grab a piece of paper, please. Okay, so write the multiplication expression from exercise 2 using improper fractions. So improper fractions, we've talked about these in the past, but I want to go over them again. Now, when you're doing improper fractions, all right, it's only time you can do is with a mixed number. So when you have a whole number and a fraction, this is the only time you can make an improper fraction. All right, just if you have this, that's a proper fraction. You can't do anything with that. Don't mess with it. This one we can change to an improper fraction. Now, to do that, you take the whole number times the denominator. So what's 1 times 4? 4. Okay, then you add the numerator. So what's 4 plus 1? 5. So you get 5 as your numerator. So we're going to put that 12 again. Times 5 over, and you keep the denominator, 5/4. So in reality, it'd be 12 times 5 over 4. Now, what does 12 go over? Since it's a whole number. Zach? 1. Okay, so that's how that would work. All right, let's go ahead and go on to the next page. And we're going to talk about multiplying a fraction in a mixed number. All right, so to multiply a fraction in a mixed number, you need to change the mixed number into an improper fraction first. Okay, you always got to turn it into an improper fraction before you can multiply. So if you have 2.5 times 1/4 like they have here, all right, well, they changed the 2.5 to 5 over 2, because what's 2 times 2? 4. What's 4 plus 1? 5. So you get 5 over 2. So now you have 5 over 2 times 1 over 4. Okay, you just multiply across like we normally do. So 5 times 1, 5. 2 times 4, 8. Can you simplify 5 over 8? No. So you're done. That's all they want you to do. Guys, it's just multiplication. It's nothing crazy. It's nothing out all craziness. Nothing like that. It's just literally multiplying it. So like this one, 1/3 times 1 3/4. So we have 1/3 times 1 3/4. fourths. Okay, so the first step here is to change this into an improper fraction. So I'm going to leave that 1/3 alone. I'm just going to bring it down. Now, how do I change this to an improper fraction? What do I have to do? What do we have to do? Yep, so what's 1 times 4? Well, and then what do we do next? Camden? Add 3. So what's 4 plus 3? What's 4 plus 3, guys? 7. So you get 7, and you just keep the same denominator, 7 over 4. Okay, now we just multiply. What's 1 times 7? 7. And 3 times 4? 12. 7 twelfths. Can't simplify that, so you're done. It's easy as that. So the one extra step you have here is just to change this into an improper fraction. That's it. And then you just multiply. All right, so let's do this one. Don't worry about the estimation part. We're not doing that. All right, so we have 5½ times 1/3. All right, they want you to write in simplest form if you can. All right, now 5½, we got to change this. So does anybody know what that improper fraction is going to look like from 5½? What is 5½ going to look like? Carly? 11 over 2. She did 5 times 2, which is 10, plus 1 is 11, and you just keep the denominator. So what this means is that it's 11 times 1 on top and 2 times 3 on the bottom. Oops. There we go. So what is 11 times 1? 11. And then what's 2 times 3? 6. Okay, so this is an improper fraction here. The numerator is bigger than the denominator. So what I want you to do is we need to turn this back into a mixed number. So how many times does 6 go into 11? Nope. Jacob? Once. Okay, so you get 1 as your whole number. Now, if we take 6 away from 11, what's left? Huh? If I take 6 away, so I subtract 6 away from 11, what do we have left? Cameron? No, 6. So what's 11 minus 6, guys? 5. So 1 and 5, and then you keep the denominator, 1 and 5 sixths. So it's 11 over 6 or 1 and 5 over 6. Easy as that. All right, let's do one more. So jump over to page 284. Okay, so it says multiply and then write in simplest form. So number 1, we have 1/2 times that 2 3/8. So remember, our first step is to change it into an improper fraction. So what do we have to do to that 2 3/8 to make it an improper fraction? What are we doing? Camden? Yep, 2 times 8.
Which is 16.
Yep.
So, and 16 plus 3 is 19.
Yep, so we get 19 over, and then you keep the denominator, over 8. Okay? So now we can just multiply this across. So it's 1 times 19, which is 19, and then 2 times 8, 16. Okay, can we simplify this? Is there anything we can divide out of both of these that we can simplify by? No, there's not. 19 is a prime number. You can't do anything. But we can change this back into a mixed number anyways. So how many times is 16 going to 19? Just once. Okay, if I take 16 away from 19, how many do we have left? 3. And then we just keep our denominator, so 16. So here's your 2 answers right here. Okay? All right, so I want you guys to go back, and I want you guys to do A and B at the bottom of page 282. So you're doing A and B. Okay, so you're just multiplying those out, and then you solve them. All right, here we go. So letter A, we have 2/3 and times 2½. Okay, so who can walk me through this one? What do we have to do for this one? Zach? So you got to change that into an improper fraction first. So I'm going to write this 2/3 times. Okay, so walk me through that again. So 2 times 2, which is? Okay, and then what do you do? Okay, so what do we get? 5. So 5 is our numerator. And then what's our denominator? 2. There we go. Okay, so let's go ahead and multiply this out. What's 2 times 5? 10. Oh, I keep losing my... Oh, because I can't go down any further. Okay, and then 3 times 2, 6. All right, so can we simplify this? We have 10 and 6. Can we simplify it?
Yeah.
Yeah, by what?
2.
2. So then you get 5 over 3, because you got to divide a 2 out of both of these. Remember, it's got to be in simplest form. Now, we get 5 over 3. Can we go any further than that? No. So that's the improper fraction answer. Now, if I turn this back into a mixed number, what's that going to look like? How many times is 3 going to 5? As close as we can get to 5. How, Camden? Once. And then what's left over? If I take 3 away from 5, what do we have left? 2. And then my denominator stays the same, 3. So 5 thirds or 1 2/3. Okay? Any questions on that one? You guys got to remember, you have to put it in simplest form. All right, so let's do letter B now. So we have 3/8 times that 3 1/3, but we got to change that into an improper fraction. Okay, so what's 3 times 3? 9 plus 1, 10. So we get 10 over 3. Now, before on letter A, I just went ahead and multiplied. But remember, when we did multiplication with fractions, I taught you how you can simplify before you multiply. That is perfectly fine. But you got to remember, they're diagonally across if you were going to simplify. Now, can we do anything with 3 and 3? Can I divide anything out of these two? Yeah, what? 3. Guys, if it's both 3, we can divide a 3 out. All right, I'm going to write this right here. So I get 1 up here. And now I get 1 down here. Okay, now 8 and 10. Is there anything I can do with 8 and 10? Yeah, what? 2. We can divide a 2 out. So I get 4 down here. Close enough. And 5 up here. So then what's 1 times 5? 5. And 4 times 1? 4. You don't have to do this method, because you could have got 30 over 24. But is that in simplest form? No, because you got to get down to that 5 over 4. Like I said, that's why I like to simplify before I multiply, because then I know that this is simplest form. Whereas this, you got to keep working with that. Okay, that's not wrong. It's just not in simplest form. All right. So then if that turns back into a mixed number, we get 1 1/4. Those are your 2 answers right there. Okay. Any questions on this? Yes, Camden.
We can't do like the method of like dividing out the number from like the top and the bottom, like if you would have to divide 6 out of 30 and 24.
Yep, exactly. So you still have to simplify this. So you divide a 6 out, and you get 5/4. So you still get the same answer. Just 2 different ways of getting there, just depending on when you want to simplify. Like I said, I just like doing it early because then I don't forget. It's your preference. I don't really care. So it'll up to you, whatever makes it easy for you. All right, so on the next page, now we're going to do just mixed numbers times mixed numbers. So you got one extra thing that you have to do. You got to change both of them into mixed numbers or improper fractions. So like this one, example number 3. Okay, so we have 1 7/8 times 3 1/3. Okay, so we just got to change them first into improper fractions. So 1 times 8 would be 8 plus 7 is 15. So we get 15 over 8 times. Now 3 1/3 would be 3 times 3 is 9 plus 1 is 10. Okay. Now, like I said, you can simplify before you multiply, which I'm going to go ahead and start doing. So 15 and 3. Is there anything I can divide out of 15 and 3? 3. I can divide a 3 out of both of these. So I'm going to divide a 3 out. So I get 5 on top and 1 on the bottom. Now, what about 8 and 10? What about 8 and 10? Camden? 2. The other reason why I like doing this first is because it saves you from getting a bunch of big numbers. So then if you wouldn't have done this, you would have done 15 times 10, which is 150, over 24. That's got a lot harder to work with than what it's going to be. So 8 divided by 2 is 4. 10 divided by 2 is 5. So now what's 5 times 5? 25. 4 times 1? 4. Okay, so we get this improper fraction. That's in simplest form because we already did that. Now I just got to change it into a mixed number. Well, 4 goes into 25 6 times. Well, 6 times 4 is 24. If I take 24 away from 25, how many do I have left? 1. So there you go. Are there any questions on multiplication with mixed numbers? Nothing crazy on it, nothing like that. You just got to remember to do these steps. Now, the other thing they're going to throw at you is just a story problem. It does not change anything. You're still just multiplying. So like this one, they had 4.5. The Hoover Dam contains 4.5 million cubic yards of concrete. The Grand Coulee Dam in Washington State contains 2 2/3 times as much concrete. How much concrete does it contain? Well, you just multiply those two numbers. So you got to change them into mixed numbers or improper fractions, multiply them out, and you get 12. Well, that means there are 12 million cubic yards of concrete in that the Grand Coulee Dam. Okay? So even when you get a story problem, all you're doing is multiplying. Okay? So don't freak out when you see a story problem. Still just multiplication. So I want you guys to try to do letter C down at the bottom. Okay? Read through it, see what they're asking, and then if it's multiplication, multiply it out. Change them both into improper fractions, then multiply. So go ahead and get to work on that. All right, here we go. So Mr. Wilkins is laying bricks to make a rectangular patio. The area he is covering with bricks is 15.5 feet by 9 3/4 feet. Anybody know what those two mean? Like those are measurements, but what are we talking about if he's making a rectangular patio? Thank you. The length and the width, guys. So if you find in the area of a rectangle, all you're doing is multiplying length times width. So all you're doing is multiplying these two numbers here. So we have 15.5 times 9 3/4. So what is the first thing we have to do? Oh.
Multiply 15 by 2.
So we got to change them into improper fractions. So 15 times 2 is 30, plus 1 is what? 15 times 2 is 30, plus 1, 31. So we get 31 over 2. Times, now we got to do 9 times 4, which is 36, plus 3 is 39 over 4. Okay, if I want to simplify before I multiply here, all right, 2 and 39 don't work. 4 and 31 do not work. So guess what? We have to multiply it out. So 31 times 39. Well, 1 times 9 is 9. 9 times 3 is, anybody? 27. Okay, now I come down, put a 0, and then go back up to the next number, 3. So 3 times 1 is 3. 3 times 3 is 9. So now I just add these up. So 9, 10, 11, 12. So 1,209 over, what's 2 times 4? 8. Okay, so this is an improper fraction. Normally, okay, we got to see, I would rather you guys, especially when we're using a story problem, I want you guys to put it in a mixed number, okay? When there are like feet, inches, measurements involved, turn it into a mixed number because there's no way you can put the measurement of 1,209 over 8 on a ruler. It's very, very hard. You won't be able to figure it out. So let's change it back into, so we got to figure out how close we can get to 1,209 with 8. The best way to do this is just divide it out. And whatever your remainder is your numerator. That's the good thing about this. Okay, so how many times does 8 go into 1? Doesn't. So we got to do it out of 12. How many times does 8 go into 12? Once. Okay, so that would be 8. We subtract, we get 4. Well, that doesn't work, so I got to bring my 0 down. How many times does 8 go into 40? 5 times. So that goes above the 0. That's 40. Get left with nothing. Bring down my 9. How many times does 8 go into 9? Once. That's 8. So this remainder here that we've talked about in the past, that's your numerator. So your whole number is this answer here. So we get 151. We have 1 left over, so 1 over our denominator. Okay. Oh, sorry, feet squared. Or you could put square feet. Huh? 8. So it's 151 and 1/8 square feet for his patio. Yeah, you can write square feet or you can put feet squared. I always do it with feet like this. Just easier to write that. It's quicker. Yep. All right, and the last thing you would see is on the next page. Okay, it's example number 5. You guys are still doing the same thing, but then they're going to throw a whole number at you. So what do whole numbers go into over in a fraction? 1. Okay, so it'd be 8 over 1. All right, easy as that. Any questions? All right, so now I'm going to have you guys go to IXL on your computers, and you guys are going to work on 6th grade K, what was it? K13. So 6K13. All right, and you need to get to a score of 80 or higher. The closer you get to 100, the better off you're going to be. Okay, so that is your homework.